Well, today we are going to talk about refrigerant gases. Refrigerant gases can be grouped or classified in various ways. The usual, the generic, would be the classification by composition. If it has chlorine, fluorine, and carbon, they are CFCs. If they have HCl, F, and C, they would be HCFC. Therefore, we have multiple classifications. They are interesting, but they are too generic. What interests us? We are interested in the classification by security group. We'll see that we have three big security groups, where one of them is divided into two. As a high security group, we have refrigerants that are neither flammable nor toxic. Those are the conditions that we are going to use, or the characteristics according to which we are going to carry out the classifications, based on their flammability and based on their toxicity. Individuals in the high security group are not flammable or toxic. Individuals with medium security possess either toxic or corrosive properties, or they can be flammable or explosive depending on their specific characteristics. When they have a concentration above 3.5% by volume, that is, they must have a minimum concentration in the air to result in any of these characteristics, such as flammability or toxicity. There is a group that is the Al within the L group that has a higher security. They are a little safer. They do not reach the L group, but they are there in the middle. These belong to group L, but they possess a characteristic, namely, their combustion speed is lower than 10 semi-kilometers. Therefore, this subdivision was established in a way that allows the introduction of the R to create a distinction in terms of properties related to refrigerant charge, particularly in the aspect of refrigerant charge. This is the area that is most impacted, as we will explore in a subsequent video. Security group L refers to substances that are flammable or explosive with concentrations below 3.5%, indicating a very low concentration level that poses a potential risk. We can already see its effects. This is the table where all the security groups are seen and how those flammable or toxic characteristics are increasing or decreasing. As a high security group, we only have the letter A. What is the meaning of L and UN in the context of this discussion? When we have A, it is low toxicity. When we have B, it is high toxicity. And the accompanying number 1,2L, 2 or 3 indicate how its flammability is increasing. Therefore, as a security group, we have said that only those from group A are present. As a security group, we would have both BL, BL, A, and B. And as a low security group, we would have the A's and the B's in our possession. What does it mean for a refrigerant to be flammable, or how is its flammability measured? We must consider two concepts. We have to know what the lower flammability limit is, which we will see later, which are tabulated. There is a list where all these parameters are for each of the refrigerants. The lower flammability limit indicates the minimum refrigerant concentration that can propagate a flame in an air and refrigerant mixture. That concentration will provide information about the source of ignition, and the upper flammability limit will give you the concentration at which there is already an excessive amount of refrigerant, making it impossible to create a flame. Why? Because it has been able to displace oxygen, and without oxygen there is no flame. Based on flammability, there are three categories. Category 1 includes non-propagating refrigerants tested at 60 degrees and 1 atm. Category 2, which must meet the three characteristics, show flame propagation when tested at 60 degrees 1 atmosphere, and have a lower flammability limit when they have a concentration greater than 3.5. It is necessary for it to have a moderately high concentration for them to produce that flammability, and also it has a lower combustion heat of 51,900 kilojoules per kilogram. Category 3, of course, is going to be just the opposite. It's going to do things that Category 2 is not capable of doing. Here they show propagation equal to before. They show propagation when tested at 60 degrees Celsius 1 atmosphere. It has a lower flammability limit below 3.5%. That is, with low concentrations capable of combustion, and its heat of combustion is greater than 19,000 kilojoules per kilogram. We already know that there are three categories for flammability and two for toxicity. Category A would be a refrigerant whose concentration over time has no effect on a worker who is exposed to that refrigerant for 8 hours a day and 40 hours a week. And that threshold concentration value, let's say, is 400 ml cubic meter, which when we talk about milliliters per cubic meter, we can talk in parts per million, which is more commonly used, okay? Milliliter M3. If you convert volume, you'll see they are parts per million, ppm. Category B refrigerants have an impact on individuals when they are exposed to concentrations below 400 parts per million. This implies that even minor concentrations in the atmosphere can have an effect on the body. All we've seen is refrigerant, but we've discussed it at a general level. What we've actually done is talk about pure refrigerants with a single component. We already know that the majority of the refrigerants, or a large number of the refrigerants we use, are mixtures. Well, this mixture can be categorized into two types. It can be azeotropic mixtures, which implies that the liquid phase and the vapor phase have identical compositions. If we place an azeotropic refrigerant in a container, the composition in the liquid phase and the composition in the gas phase within the container are identical. Why? Why do both have the same boiling points? That is, when one boils, the other boils. So if there is a 50-50 composition below, and both evaporate into gas, we will have a 50-50 or 40-60 composition. What does it mean to be a ceotrope? Ceotrope? It means that one of the two refrigerants, or three or four, the mixtures can be made up of any desired components, will start to evaporate or boil earlier, which means there will be more of that refrigerant in the gas than in the liquid. Is there an imbalance? That's why it is said that when we have it depends on the refrigerant, like 400, etc. And we have a leak, we need to remove all the refrigerant from the machine and put back 407C pure, well, pure with the initial mixture exactly as it was before. Why? Because when that leak occurs, we don't know which of the refrigerants has evaporated. Normally, the one with the lower boiling point evaporates more, so we no longer have 407C, we would have something completely different. Well, when we have the mixtures, when these imbalances occur due to unequal evaporation, we can find that we can classify the refrigerant in one way when it has the initial concentration or composition, and in another way when it has that leak, which we do not know how it leaks because one of the components evaporates first. With all of the classifications that we have previously observed, including the mentioned categories A, B, and B from before. When handling mixtures, it is essential to assign two classifications and separate them using a slash as a delimiter. The first one will be the classification with the initial composition of the refrigerant, and the second one will be the classification with the worst imbalances that we can encounter in the event of a leak, in the event of evaporation decomposition of that refrigerant. Well, now that we have seen the classification, let's see why we call them, how it is done. To make a call to a refrigerant, RASRE he established a standard. All the documents he desires are referred to as standard. And in this instance, it is named Standard 34, where he provided a set of guidelines for naming refrigerants. We will see that this is worth both to name it and to know things about it when we have the name of a refrigerant. If the refrigerant's base is methane, it will be classified as part of the 0 series of refrigerants. If they originate from ethanes, that is, with 2 carbons, it will be classified as series 100. Propane, 3 carbons, it will be 200. The ceotropes will be 400. The azeotropes 500. The organic ones will be 600. And the inorganic ones will be the family, the series of the 700. Let's observe how it is done. If we possess series 100 or series 0, that is, if they originate from methane or ethane, we will possess 4 numbers. This can also be applied to the 200 series, but I have left it as it says there, Ray 34, so as not to distort it. But it would be the 0 series, the 100 and the 200. In fact, there is an interesting case. The 200 we are going now has 4 digits. You will say, well, I have seen refrigerants with 2. Okay, those unseen digits are zeros, they are 4 digits, and they are read, named, or named from right to left. The first digit, the one on the right, will be the number of fluorine atoms in the compound. Then we will have to know the molecule in order to be able to name it. That would be the one on the far right, the one next to it. The second one would be the hydrogen atom number, and we add 1. The following would be the number of carbon atoms, and we remove 1. And the 4th digit would be the number of double links. In this fourth digit, only one refrigerant I know. Two refrigerants have it, which are 1233, 4Z, and if. Let's see now the case, because double links are not very common. In fact, as I mentioned, I only know two cases, but they do exist. If we possess a molecule in which, by altering things around while leaving the identical pieces and atoms intact, we are able to achieve a distinct molecule, this phenomenon is referred to as isomerism. Isomerism is the concept I have mentioned, referring to a molecule where we alter the arrangement of atoms. Now we will see it later. If a compound has isomerism, that is, you can create several compounds with the same pieces, we would have lowercase letters. In lowercase. That is the reason why now we will observe that the 407 as an uppercase C, not a lowercase 1, where different letters, the one that has the most symmetrical, would not have a letter. And then the asymmetries would be generated from letters A, B, C. In the event that we have the 400 series, which are the pheotropic blends, we would also possess letters assigned based on their composition. If we have an azeotropic mixture with two compounds, if we alter that composition, for example, from 50 to 50, we could call it I don't know how much A, and if we do a 60-40, I don't know how much B, they have the same compounds, but in different concentration, then they will be different refrigerants. If the mixture is azeotropic, that is, from the 500 series, they do not have an order, but numbers are added to them later based on how they appear. If they're inorganic refrigerants, we'll also see it now, they'll be from 700 series. And what we do is incorporate the molecular weight of the refrigerant into that 700, with which now we'll see, e.g., water is a coolant, as all we must do is say 718, 78R, 718. It would be the water. Let's see some examples. Well, the R, when we know its molecule, we see that it comes from methane because it has a single carbon. So this would no longer be R, it would be R. But for simplicity, it is called R, which is an abbreviation for the word reduced. How is the nomenclature done? The first two, that is the part to the right, would be the number of fluorine atoms, 2. This other 2 would be the number of hydrogen atoms, 112. And the carbon atom number, 1.0. Does it have double bonds? No, another 0. Then this would really be an R. How to do it? With 134A, is it fine? 134. To start, we know it's an isomerism, lowercase letter, okay? It is isomerism. If we replace this hydrogen with fluorine, we would obtain a different molecule with refrigerant properties. It would not be Ra, it would be a lowercase r, b, c, d, or whichever one it is. How is the nomenclature process done? Well, the isomerism has already been done by someone else. It is not explicitly stated. There is no explanation provided regarding why it is like that. Well, if there is an explanation that it is very symmetrical, but well, that would be getting into chemistry. But if we look at the numbers, we would see that the atomic number of fluorine is 444. Hydrogen has an atomic number that is reduced by 2 and then increased by 1, resulting in a total of 3. Carbon has 2 atoms, with 1 double bond and no other bonds. Then this would be the ratio to the reactant as it originates from the good one. We have not explicitly mentioned it, but this particular one is derived from ethane due to its composition of 2 carbon atoms. The R comes from methane because it only has 1 carbon, so we would do the same. This would be an R. The total number of fluorine atoms is 2. The count of hydrogen atoms is 2 minus 1.2 plus 1. I apologize, 2 plus 1.3. The count of carbon atoms, subtracting 1 for those that are not double bonded and do not have another 0R, is equal to 0. Well, and this is the situation where everything begins to converge and we observe that compound that is seldom referred to by its 4-digit name, even though all of them consist of 4 digits, some of which are 0. However, in this particular case, none of them have 0 as the first digit. Well, it is derived from propane, and then it forms a series of 200. The first digit to the right in the series would be a 4. Why? Because it would be the number of fluorine atoms in the molecule, 4. The next one would be the hydrogen atom number, 2, 1.3. The following would be the number of carbon atoms, minus 1, 3, 2, 3, 1, 2. And the double bonds, when it gets a bridge, here goes and how we can make isomerisms. Imagine the turns we can give to all these atoms for more possibilities and variations. We can change this for this for this, and when we have all those changes, now you do the same, but change the double link, which means there are many. That's why it's a Z. It seems that isomerism is just one letter, but when there are so many, they become those slightly complex surnames. For example, one isomerism that could be done would be to change this fluorine's position, place it here, and change this hydrogen's position and place it here. At that moment, this would no longer be a 234Z, it would turn into 1.23. Yes, is it 4? Why? Because it has the same number of fluorine, hydrogen, and carbon, but it is not the initial configuration that it had before. In fact, this change makes this be called R234 and F. Okay? That's why we have those two isomerisms. Regarding refrigerants in group 700 for inorganic ones, we have mentioned that the value would be 700 plus the molecular weight. For water, the value is 16. As for oxygen, it is 2, and for hydrogen, it is 18, 7, or 18. Ammonia would be 14, from nitrogen plus 3 hydrogens, 7, 1, 17. When referring to carbon dioxide, the chemical formula would be 12 carbon plus 32, which is 16 times 2 in oxygen, resulting in a total of 744. This is very easy, okay? Well, we have seen how they are classified. That is, various classifications of refrigerants. We have seen what they are called or how they are named and what those names mean. Let's see other properties tabulated in RECIFE in safety regulations for refrigeration installations, which are interesting. Practical limit is the maximum permissible concentration for safety expressed in kgmm3 of refrigerant gas in an inhabited area. It means that if we have a team that is air conditioning a room, that practical limit, apart from other things. But this would be the first way to see how much refrigerant load the machine can have. Because if the machine is located inside, that is the batteries, in this case, the indoor unit. If we work in cold mode, the evaporator, if it has a leak, everything will leak inside the premises. And depending on what refrigerant group we are in, it can have consequences, it can have another. So first, the first step to know the refrigerant charge of a unit, if the unit, for example, was outside, which is a chiller, and what goes inside the premises are water pipes, in principle, there is no problem because the discharge will be done into the atmosphere. So the initial load or the initial concentration that we need to consider, that we need to encounter in a team, would be its practical limit LP, which is measured in kilograms of refrigerant per cubic meter of the occupied room that it air conditions. The ATL, which would be the acute toxic exposure limit at the maximum recommended refrigerant concentration, recommended according to the standard with the regulation, the 378 one, and intended to reduce the risks of a dangerous acute intoxication for humans in the event of a refrigerant leak. Okay, well that would also be another way to see how much refrigerant charge a unit has. The ODL would be the oxygen deprivation limit. We have observed that there existed an upper flammability limit wherein the refrigerant ceased to induce a flame. Why? Because it displaced the oxygen. So without oxygen, that flame cannot be produced. So what the ODL tells you is how it displaces oxygen, that 18% of oxygen that we normally have in the air, with what charge, with what concentration it is capable of displacing it and causing asphyxiation. The PCA, which is the potential for atmospheric warming, you know it more as the GWP, which tells us what warming power in the atmosphere it has compared to 1 kilogram of carbon monoxide. In other words, if we state, for example, that a refrigerant has a GWP of 1000, it signifies that it has a 1000 times greater atmospheric warming potential than CO. Okay? Now, the refrigerants we are using, almost all of them are below the butt. What we try is that they are below 650, 675, 152. For example, the 12334Z seems to have a WP of 7. Now we are going to look for it, okay? We are looking for refrigerants that have very low global warming potential, very low atmospheric warming potential. Then we have the POW, which would be the potential for ozone depletion. The ODP called ozone of plethysmon potential, which tells us how it affects the ozone layer. Almost all refrigerants have ODP. It is almost imperative. In the table, we'll see many refrigerants that do, but since they have a different ODP from 0, it's normal for them not to be used anymore. And then we have the rep, which will be the classification of refrigerants according to the pressure equipment reg. We will observe that in another video, and we will observe how, depending on which refrigerant is utilized, it will possess a classification, and therefore the equipment will have the capability to pass or not pass. The regulation of pressure equipment is another distinct concept. Well, to observe the characteristics of refrigerants, it is advisable for you to visit and search for this on the internet. As a rule, I typically utilize Consolidated Bank of England, Royal Decree, or Receives, or 552019, if that is acceptable to you. Anyway, here you have the address. You don't have it, but well, if you put that BOE Receive Consolidated, or it will take it here. Okay, what we have there? Well, we have this table in the Appendix 1 in Table A, where it talks about all the existing refrigerants, or that Receive contemplates as such. What are the characteristics of each one? Well, we have your security group, okay? Would this be in Group L? If we keep going down, we would come across refrigerant from Group L, The security classification that we have here, what does it mean when it only has the letter A as its designation? That they are not mixtures. For instance, in this case, we already have a 410A mixture. That A is because it is a ceotrope. If not, it would be lowercase because it would be an isomerism. Does it mean that when you have the initial composition, it is from Group A, and in the worst case, due to a leak, it would still be from Group A? Take note of how Ra is denoted as the lowercase letter r with a numerical value of 154, indicating isomerism. Additionally, it is represented by the number 124 in what composition? In this, a 53% by weight of R, a 13% by weight of 152 to 1, 34% by weight of 124. What could we see differently? Here we have been stating it all the time, 410, and it is 401. The 401 alpha, Bravo and Charlie, each one has a different composition, even though they have the same components. All three have the elements R, A, and 124, but their compositions are completely different. In every case, when it has the initial composition, it is classified as part of Group A. Even when it has the most severe imbalances, it still remains categorized as part of Group A. Then we would have the denomination of the refrigerant, its name, its formula or formulas, its molecular mass, the vapor density, the practical limit. That is, we could already say that with R, we could not have a refrigerant charge in the machine greater than 0.3 kilo m cubic of the room. It climatizes its boiling point, the ATL, which is when it has severe intoxication, the ODL, which is when it displaces oxygen, since we see its concentration in kilograms per cubic meter, the autoignition temperature, the lower flammability limit, the global warming potential, the PCA 100, because it refers to what we have commented before, which refers to the warming power of CO in 100 years of life. These refrigerators have a lot of life. They could last much more than 200 and 500 years. They have many years of life in the atmosphere. So that potential for atmospheric warming can be measured in different ways. But the reference we always use is that of carbon monoxide over 100 years. The ozone depletion potential, ODP, notice how zeros are already starting to appear here. And if we look at the most commonly used refrigerants, 407C, 0, meaning that it is almost imperative that it be 0, that they do not harm the ozone layer. And subsequently, the classification pertaining to the pressure equipment regulation, okay? What can we observe that is something peculiar or unusual in nature or circumstances? As we have seen previously, the 1234Z, observe how the 1234Z, the Z, and the IEC, even though they have the same components, undergo a change in the double bond. I apologize, but is the double bond changed or not? Well, what we have seen before, they have carbon, carbon, fluorine, fluorine. They have the same components, but altered in the molecule, okay? Which one could we see a little more interesting? To give an example, let's consider the 410, which we have A and B in uppercase. What does it mean precisely? Can you provide some clarification? What are two compounds? It is a compound. It is a eutectic mixture with two different compositions, either 50% by weight, or one has 45 and the other 55. In both cases, it has the same classification with the original composition or with the most altered composition. The classification remains consistent regardless of whether it is the original or the most altered composition. Isomerism, well, the one we have seen in 123.4Z and the if, that would be an isomerism. And well, from here you can obtain a great deal of information because you can thoroughly analyze this table and extract all of its characteristics or a portion of them. In fact, we'll see in other videos how all these values, or most of them, are used to determine the characteristics that the equipment must have to be in accordance with RECIFE, or for example, with the pressure equipment regulations. Okay? Well, for today we'll see each other in another video with more coolant. See you later.